I'm Aditi Kinkhabwala from New LG Institute of Engineering and Technology. Let us continue with the topic of stack, which is part of Unit 2, Linear Data Structures. Students, in the last lecture, we had a brief overview about applications of stack. So we did see that stack is useful in reversing a string, for parenthesis checking, for expression conversion, expression evaluation, function calling, memory management, backtracking, and syntax parsing. Let us see in detail few of the applications of stack. Now students, stack is a very important and effective data structure to evaluate arithmetic expressions in programming languages. Now students, in your C language, you must have done programs of like converting Fahrenheit to Celsius or Celsius to Fahrenheit, finding area of a rectangle, triangle, circle, and so on, which has certain equations. So those equations are nothing but arithmetic expressions. Now, how they are evaluated at the back end, right? So basically, we need to understand that. And one of the important data structure which does that is stack. Right? Now, let us see what is an arithmetic operation first of all. So, arithmetic expressions is basically consisting of operands and operators. So, what are operands, students? So, if I say A plus B, so A and B are the operands and plus is the operator which works on these operands. Also, along with operators and operands, we have arithmetic operations which have brackets, such as left parenthesis and right parenthesis, which are opening and closing brackets. So, what is an example of an arithmetic expression? So, this is an arithmetic expression, we can say A plus B minus C, right? So, what is A plus B minus C? So, basically, in order to evaluate this expression, we should know two things. That is precedence rule, because mathematically when we solve this equation, this expression, we need to know the precedence rule. That what is the precedence rule and which operators are of higher precedence. Also, once we know the precedence, we should also know the associativity. Now students, when I say A plus B minus C, right? So we should know which operator has higher precedence for calculating that part of the expression first, right? In order to evaluate certain portion, first we need to see the precedence. We know, students, that the precedence of exponential is higher, then comes multiplication division, then comes addition subtraction. So addition subtraction has the same precedence. When I say A plus B plus C, this time this plus and this plus has the same precedence. Now, when the operators are having same precedence, we need to look for associativity. Now, can you see here that the associativity is from left to right? So, in case of same precedence, it is evaluated from left to right. Similarly, multiplication and division is also left to right and exponential is right to left. Okay, so in order to evaluate arithmetic expression, stack requires two steps. So it first converts the expression to a special notation. So that we will see what is this special notation, and then with the help of this new notation, it will evaluate the expression. Now, what is this special notation? So basically, an arithmetic expression can be represented in three ways, which are infix, prefix, and postfix. So, what is an infix notation? It is a convenient way of writing expression in which each operator is placed between the operands. So, A and B are operands, and if the operator is between them, we say that it is a infix notation. So they can be, infix notation can have brackets, that is parenthesis can be there, or there may not be any parenthesis depending upon the problem. A plus B, C minus D, these are infix operators. Next is prefix operators. Here we have operands and the operator is placed before. The word pre says means before, right? So this notation was introduced by Polish mathematician and hence it is also known as Polish notation. So generally in textbook also you will find this notation name as Polish notation. So this Polish notation is nothing but these notation which we are studying, that is infix, prefix, postfix is known as reverse Polish notation and so on. So can you see here AB and plus is operator is before this AB and CD minus is before CD. So it is a prefix notation. Operators come before the operands. The next is postfix notation. Postfix notation places operator after the operands. So if these are operands, plus is placed afterwards. And this notation is reverse of this Polish notation, which is prefix. So this is known as reverse Polish notation, such as AB plus, CD plus, so on. All these expressions are in postfix notation. We have to understand because the operator here comes after the operands. So students, it is very easy for an algorithm, or it is very easy for computer to understand arithmetic expression if it is converted into prefix or postfix using stack. So first an expression has to be converted into prefix or postfix and then it is evaluated using stack. Okay, so here are the examples of the infix and corresponding prefix and postfix notation. So it is A star B, so star AB and AB star. A plus B slash C, that is divided by C. So prefix would be AB plus and C and then it has this slash. So slash plus ABC and here AB plus and C slash. Then this is AB, so star AB, then minus DC and both of this, the plus will come in prefix, right? So we will understand that how we can convert infix into prefix and postfix. What is the postfix? So A plus B is AB star, D minus C is DC minus, and the plus between these two is at the end. This is the postfix notation. So how this infix is converted into postfix, that we will see first, and then we will see how infix is converted into prefix, right? So students, when the algorithm converts the infix to postfix and then we use this stack to push operators and pop them, evaluate them once we come across this star plus minus operators. So operands are pushed and once onto the stack and once operator comes, so we can say once the operator is inserted or once we have the operator scanned, we can output or we can just place or calculate, evaluate the whole equation. Now, let us see how we can convert this infix to postfix notation. Let us see the first algorithm known as unparenthesized suffix. Unparenthesized means the string which is given or the equation or expression which is given does not have parenthesis. So, bracket would not be there and we have to convert it into suffix. That means postfix. Okay, it is also known as reverse Polish. Basically, this algorithm converts infix to postfix and evaluation is performed in such a manner that operators with the precedence, the higher the precedence, they are evaluated first before the others, right? So we will see how infix string is calculated to postfix and this postfix string then stack uses this and evaluates the expression, right? So if more than one operator has the same precedence, then we will see the associativity. Right, so let us see the algorithm for unparenthesized suffix and this is the precedence table given and the rank given for each one of them in order to calculate the rank and precedence. So plus minus has precedence 1, star multiplication greater precedence, variables has even greater precedence, rank of variables is 1 and others rank are -1. And based on this table, we would be able to solve infix to postfix. Now students, again, operator precedents are what? Brackets are solved first. Then we have unary, plus, minus, not operator, then multiplication, division, addition, subtraction, and this is what we have studied in PPS, right? So we will go according to this precedence table in order to solve our problems. Okay, so the algorithm goes like this. We have a input is what? Infix string. So it could be any string such as a plus b star e minus d divided by h, any infix string, right? And these all have some kind of precedence. A, B, E, D, H they are variables, so their precedence is 3. Plus and minus has precedence 1, and star and slash division has precedence 2. Okay. S here is the stack, and next character, this is a function which we would be using in the algorithm, which is a string function which is giving us the next character. Okay, so now let's have a look at the algorithm. So first of all, we have to initialize the stack. Now, I'll just take you to the example also in order to understand how this algorithm works. So see students, if this is the string and we need to convert it into the postfix notation, the string is a plus b star c minus d slash e star h. Okay, so this is the string which has to be converted into polish. Sometimes it is written as reverse polish, right? So for suffix, it is reverse polish. Sometimes for infix and prefix, only polish word is used, right? Now students, we have to initialize the stack. We have to declare top as 1, and s of top means a stack. The top of the stack is hash. So now let us initialize this. So here we have top is equal to 1 and s of top. What is s of top, students? Currently this is the stack. Content of stack. Here we will place a hash symbol. Right, so our step 1 is over, in which we have initialized the string. Now let's go to the step 2. What does step 2 says? We have to initialize output string, which is our postfix, and the rank count. Initially rank is 0 and string is empty. So can you see here, the rank is currently 0, so rank would be 0. Okay, and the string is empty. Currently it is blank because we have not started the process. Now let's see the third thing. We have to get the input symbol. So how can we get this? We are using the function called nextChar. This function will return the next character from this infix string. Given string is infix, and it will go to the next. Okay, so what is the next character, students? Here the first character is A. So first here we would have A, right? Now what we have to do? Let's go to the fourth step. We have to repeat till step 6. So we have to repeat step 5 and 6 until next is not equal to hash, until we encounter this hash. Why this hash is required, students? So we will start with a hash and then we will fill the stack. So when at the end we again get only hash, at that time we consider that our string is completed and we have got our answer, right? So now what is the fifth step? We have to remove symbols with greater or equal precedence from the stack. So now let us see this A. So hash, and can you see this, students? We have to repeat while f of next is less than is equal to f of top. So students, if f of next is less than equal to f of s of top, then only we have to perform this pop operation. This is what? This is mostly pop operation. So what is f of next, students? F of next means this one. This is A, right? So the next character is A and currently top is 0. So if you can see here, f of hash, right? F of hash is what? 0. And f of a is what? 3. So is 3 less than 0? No, 3 is not less than 0. That means nothing is popped. We are not popping anything. We are going to step number 6, and in step number 6 it is written that we have to push whatever is there on the next onto the stack. So we are pushing this A onto the stack. So now this stack is just pushed over here, right? So this is the first step. Now next is plus. Now we have to compare the precedence of this A and this plus. So students, the precedence of A is greater. Can you see this? This 3 is greater than this 1. So in that scenario, if you can see this f of next. So f of plus is less than f of s of top. S of top means the current symbol which is on the stack. So f of a. So students, precedence of this is 3, precedence of this is 1. Yes, 1 is less than 3. So this condition is right. So we have to pop whatever is on the top. What is on the top? A is on the top. So we will pop it. Okay. So we have popped it. Then what we have to do? We have to add that into the temp. So this A will go into this temp, and we have to concate polish O temp. So we have to concate this temp. Currently students, polish string is blank and we have added A. So we are adding A to the stack, and now rank is rank plus R of temp. What is R of temp? Students, R of temp is nothing but R of A. So rank of A, if you see here, rank is 1. So here we will place rank as 1. Okay. And now after step 5 is finished, what is step number 6? We have to push the next symbol. So the next symbol is plus. A is popped and plus is pushed. Now it is B. B and plus, the precedence of B and plus is compared. If you see students, B has precedence 3 and plus has precedence 1. So B has higher precedence. So this condition will be false. Okay, so B is not less. Next symbol is not less, it is greater. So nothing will be popped. We will go to 6 and B will be pushed. So here hash plus and B is pushed, and we will have just here 1. Okay. Next is star. So now star and B is compared. The precedence of B is higher, right? So precedence of B is higher. So B is on the top. It is higher than star. Okay. So precedence of star is less than precedence of B. So we will pop. What we will pop? We will pop B here. So B will be over here. Rank of B is 1. So now rank will be 2. And after this, we will push this star over here. Next symbol is C, students. Precedence from star and C. The precedence of incoming character is greater than whatever is on the top. So when the incoming character has greater precedence from the element of the top, we will push it. So hash plus star C, this would be as it is, right? Now the next symbol is minus. Now students, if the position, if the topmost symbol in the stack has higher precedence, we have to pop it, right? So hash plus, now see students, C has higher precedence, so popped. Star has higher precedence than minus, that is also popped. What about plus? Now students, if you see over here, f of next. What is f of next, students? In next, currently we have minus. So f of minus, and at f of s of top, what we have? We have f of plus. So precedence is precedence of minus is less than f of plus, so both precedence is 1. So we can say yes, it is equal. Can you see this equal to sign? Yes. In that case, we have to pop whatever is on the top of the stack. What is on the top of the stack? Plus. So that is also pop and it will be over here. So what will be the rank? It was initially 2. On adding C, rank become 4. On adding star, rank again become -1. So again, it will be becoming 2, right? So 2 plus on adding C, it is 1. On adding star, it is -1. On adding plus, it is -1. So 2 plus 1, 3. -1, 2. -1, 1. So now this is 1. And we are pushing minus on the top of the stack. Now next one is D, right? So again, minus and D. D has higher precedence. So just we are pushing it on the top of the stack and this remains same. Now comes slash. So again, minus D has greater precedence. So popped out ABC star plus D, rank increases 1 and we are pushing the slash symbol. Now E, hash minus slash E is pushed, ABC star plus D remains same, 2. Now we have star. So what will be popped, students? As E has higher precedence, it will be popped. So here it will be E and star and slash has the same precedence. So it will be also popped and we have a slash over here. So we have 2. On adding E, we have 1 and then -1. That brings us to again 2 only, right? And minus and star are pushed, right? Minus was there, star is pushed. And last one is H. So H is also pushed over here. So A, B, C star plus D, E slash, here it is 2. Now students, we have come to an end, right? We don't have any next element. In that scenario, we are completed with step 5 and step 6. Now we don't have next character. So what we have to do when we don't have next character, then we have to pop everything out, add it to the Polish notation, change the rank till we encounter hash. Can you see? S of top, if it is not equal to hash, keep on popping. Okay, so let's see. See, currently H is there, star is there, minus is there. So everything will be popped one by one. So last in, first out. So D, E slash, first H will be popped, star will be popped and minus will be popped. Now we encounter hash. So now it is understood that S of top is equal to hash. Okay, so now we are not popping anything else and we are checking that if rank is, at last if we get the rank as 1, then our string is properly converted into postfix. So now let's see, it was 2, then we added H, so H has +1, then we subtract, then we had star, so -1 and minus, so -1. So 2 plus 1, 3, -1, 2, -1, 1. So rank we got 1. So this is our final converted string, which is ABC star plus DE slash H star minus. So this is how, based on this algorithm, we can convert a infix to postfix. Thank you.